Hey there, welcome. Today we're diving into Python tuples. Specifically, how do we get our data out of them? You can think of it like learning how to pick the lock on a treasure chest that's packed with information. So let's grab our tools and get started, shall we?
All right, here's the game plan for today. We'll kick things off with a quick look at what a tuple even is. Then we'll get into the fun stuff, how to grab single items, how to slice out entire sections, and, super important, how to check if something's even in there to begin with. Then we'll wrap it all up.
So, first things first, what in the world is a Python tuple? Honestly, the easiest way to picture it is like a locked box. You put your items in, they stay in that exact order, and once you lock it up, that's it. You can look inside all you want, but you can't change a thing.
Now that can't change a thing property has a fancy name, immutable. And it's a really big deal. It means once you create a tuple, it's basically set in stone. This is fantastic for keeping your data safe and predictable, but it also means that getting information out of the tuple correctly isn't just important, it's pretty much the only thing we can do with it.
Okay, so how do we start peeking inside this locked box? Well, the most direct way is by knowing an item's exact spot, or what we call its index. This is our first and, honestly, our most fundamental key to unlocking the data inside a tuple. The rule is really simple. You just use the item's position number inside square brackets. But here is the one thing you absolutely have to remember. Python starts counting from 0. So the first item isn't at index 1, it's at index 0. The second item is at 1, and so on. That's why in this example, to get banana, we're asking for the item at index 1.
But what if you need the last item, especially in a super long tuple? Counting all the way from the beginning would be a pain, right? Well, Python has this brilliant shortcut called negative indexing. You just start counting from the end. So the very last item is always -1. The one before that, -2. It is such a clever and efficient way to work from the back.
So we can grab one item at a time. That's great. But what if we need a whole bunch of items at once, like a whole chunk of the tuple? For that, we're going to use a really powerful technique called slicing.
The way you write a slice looks pretty simple. It's just start, colon, end, all inside square brackets. You give it a starting position, and the item at that position is included. Then a colon. Then you give it an ending position, and here's the catch. The item at the end position is not included. If you can just remember that the end is excluded, you will master slicing.
Let's look at a real example. If we slice from 2 to 5, we start at index 2, which is cherry. Then we grab index 3, orange, and index 4, kiwi. And then we stop. Why? Because the rule is to stop before we get to the end index, which is 5. See? Start is included, end is excluded. That's the whole secret.
And slicing is super flexible. If you just leave out the start number, Python assumes you mean start from the very beginning. If you leave out the end number, it assumes you mean go all the way to the very end. And yeah, you can totally mix in those negative indexes we just learned to create some really powerful slices that work from the back of the tuple.
Getting data is one thing, but what happens if you try to get something that's not even there? Well, your code will probably crash with an error. To avoid that, our next skill is all about playing it safe. We're going to talk about validation. It's like checking to see if a key fits a lock before you try to force it.
And that brings up a really common problem, right? Let's say you're writing some code that needs Apple to be in your tuple to work. How can you be totally sure it's there before you commit to running your code?
The solution is actually beautiful and simple. You just use the keyword in. You literally ask Python, hey, is this item in this tuple? And it'll give you a straight answer, true or false. No more guessing, no more errors.
And this is where it becomes a real game changer. By putting that in keyword inside an if statement, you can make your code do things only if an item is actually there. This lets you build much smarter, safer programs that don't crash just because some data is missing. It's an absolute must-know.
Phew, okay, we have covered a ton of ground. So let's take a second, bring it all together, and review the awesome new set of tools you now have for accessing tuple data.
So here it is, your complete toolkit. You've got direct access with 0 for when you know exactly where something is. You have reverse access with -1 when you need to start from the end. You've got range selection with 2 to 5 for grabbing a whole bunch of items at once. And you've got validation with in for making sure your code is safe and smart.
All right, let's just hammer home the main points one last time. First, never forget, indexing starts at 0. Second, negative indexing is your secret weapon for working from the end of a tuple.
Third, slicing is how you pull out a whole range of items. And finally, using the in keyword is your safety net. It makes sure you don't look for things that aren't there. Get these 4 down, and you're golden.
So there you have it. You now hold all the keys to unlocking tuples. You can confidently and efficiently get any piece of data you need. The only real question left is, what cool thing are you going to build with this new power?